Good morning, everyone. Just a recap of a block diagram of computer. We had already seen this: the input devices, output devices, memory storage, and the CPU, which consists of control unit and arithmetic logic unit. We already seen. So input devices gives the input. This is for storage, the primary and secondary. This is the output device, which output unit consists of output device, which gives the output, and this does the processing. Arithmetic logic and arithmetic and logic unit does the processing, and control unit will control all the components: input, memory, output, and ALU. Control is controlled by control unit. Okay, so this one we already seen. Just I'm going through slides. We had seen the primary memory RAM, secondary memory hard disk, the processor. This is an example of processor, and keyboard and output unit. Okay, we had already seen this definition also. We already know these two commonly called as CPU. Okay, input unit we are done, output unit we are done, memory unit, the primary storage and secondary storage. Primary memory, or we can say main memory, or when we say simply memory also, it is called as primary memory itself. Example is RAM. Okay, right. So primary is a permanent memory. Sorry, it's whatever data stored in primary memory is temporarily stored, and secondary memory it is permanently stored. Okay, we had already seen what does it mean. And remember, a word memory generally in memory a certain number of bits called as word. So in number maybe that it may be 8 bits or 16 bits, 32 or 64 bits, together we call as a word length. And at a time word is read from the memory. At a time a word is read from the memory. It may be, depending on the computer, the word can be 16 bit or 32 bit or 64 bits. Okay. So how the bits are maintained is by these semiconductor cells, which stores 1 bit of information. Okay. Second storage we had seen, cache memory also we had seen, frequently accessed data. We store, example is the I variable. We had done this hierarchy from left to right. I said like the memory capacity decreases. The highest memory stored in available in hard disk, next highest RAM, next cache, next registers. Registers has very less capacity, but the speed of accessing data is it's very much more in registers when compared to cache. Cache has less accessing speeds when compared to registers. RAM has still less accessing, read and write. Hard disk has still less. Okay, I had already done this and already seen arithmetic logic unit, arithmetic calculations it does, and control unit does the controlling of all the components. Okay, so arithmetic logic unit does addition, subtraction, multiplication. It takes operands the instruction and it does the addition, subtraction, multiplication. Operands here is maybe A and B are the operands in an instruction. A plus B. The addition is done by arithmetic logic unit, ALU. So we also control unit controls all this: memory unit, this control unit controls memory unit, arithmetic logic unit, and IO units. So we are dealing with this part. Basic operational concepts. In this topic we are discussing the last class. This is a topic wherein we see how exactly instruction is executed, how the instruction is fetched from memory, that is from the main memory, and it is executed by CPU, central processing unit. Okay, so this is an example of instruction. So it's like addition of these two. So addition of these two need to be done, and result is stored in R0. So loca represents to location in main memory. R0 represents to R0 represents to a register in processor. So so values in loca referred by loca and value referred by R0, both are added, and the result is stored in R0. So whatever if there is a previous result, it is overwritten in R0. Okay, right. So we are discussing about this instruction. We will discuss now how the instruction is executed. So generally when we write a program, the program, for example, addition program, add.c, addition of two variables a and b, already shown in the last class, fetching a value, that is with scanf, taking the values of a and b, adding a and b, and printing the result of a and b is a program. If that program need to be executed, that program consists of set of instructions, right? Add.c consists of set of instruction. Instruction to declare the variables into a comma b, next scanf, printf, and so on. We have instructions. So entire program resides in main memory, but instruction by instruction is fetched here and it is processed by ALU. So this happens in this processor part. In this processor part, we call this one as a rectangular box. The bigger rectangular box we call as processor. So the entire program resides in the main memory. Maybe it may be fetched from secondary memory. From the secondary memory, that is from hard disk, we get it into main memory. Main memory here is maybe RAM. From the RAM, even though we have 5 instructions in a program, example addition add.c, we fetch one instruction at a time, instruction by instruction, and it is executed by this processor part. Before that, that instruction need to be loaded in various registers. At the end, it is executed by ALU. So we'll see how the instruction by instruction is fetched from main memory to the processor part. So this one had explained in the next diagram, but before that, we will go through what these registers mean. So we already seen that part also in the last class, what these registers will do. IR, PC, MAR, MDR, these are all the registers. IR is the instruction register, PC is program counter. Can anybody say what is MAR? MAR? Students? What is the full form of MAR?
Memory address register.
Register, yes. Okay. So this is a memory, this memory address register, and this is memory data register. So these are all registers. So all these MAR, PC, IR, MDR, and these are all the registers used for storage. And control unit will control all the remaining components in the block diagram, and ALU will do arithmetic and logical operations. Okay, so this one you need to understand, because this flow you need to understand. I will show in the next diagram, which I had drawn for you. It is not available in the textbook. The next diagram I will show you. So this you need to understand, because the entire future concepts, the remaining concepts in your subject will depend on this diagram. We will elaborate all the things. Okay, right. So before that, we will understand what these registers mean. We already seen these registers also. So processor contains number of registers. One such register is instruction register, IR. It holds the current instruction being executed. So this one already we had discussed. So just I will go through quick way. And the next is program counter. It stores the address, not the instruction. Program counter stores the address of next instruction, which will be fetched and executed. Okay. So this loads the actual current instruction. IR loads current instruction being executed. This PC loads address of next instruction. So remember, if it is instruction register, instruction is loaded. And we have other in general purpose registers R0 to Rn-1. So these also used to load. They are very, only they can store only one word. So obviously operands, generally they are used to one functionality is operands can be loaded into these general purpose registers. Operands like a value, maybe a b value can be loaded, and a computer may consist of 8 to 32 general purpose registers. If there are 8 general purpose registers, there may be, it starts from R0 to R7. If there are 32 general purpose registers, it start from R0 to R31. Okay. Next is memory address registers. It stores the address of a location which is referred to in the main memory, and this one stores the data. Memory data register stores data which can be written to memory, that is the main memory. When I say memory, just remember it is main memory. So data that can be written to main memory are read from main memory. And yes. So this is a diagram I am telling about, which says how instruction by instruction is fetched from memory. So assume this is memory part. Secondary memory and primary memory together I am calling as memory. So from the memory, the data is fetched instruction by instruction. So for example, there is a add.c program in the secondary memory. That is addition of two numbers program. C program is in secondary memory. So that entire program, if it consists of 5 statements, the entire program is loaded into primary memory. And from here, out of 5 statements in the program, only one statement, or we can say one instruction also. Statement can also be called as instruction. So one instruction at a time is loaded here and it is executed by ALU. So let's see, it is not directly loaded to here and it is not executed. So in between it need to travel with travel to various registers, and then it need to be get into ALU so that it executes. So we'll see how the scenario will be, how the flow of instruction will be. So I had numbered, you can see this is 1, the numbering 2, 3, here you can see 4, 5, 6, 7, 8, 9 and 10. Total 10 steps. And remember this diagram based on the theoretical part I had drawn. Do not draw this diagram in the exam, in your exam, only for understanding purpose. So you need to write theory instead of this diagram in your exam. So this one also had already told in the last class, I guess, if I remember. So okay. So the add.c entire, so I want everyone to concentrate in this part because this one is important. So entirely future topics may depend on this diagram. So the add.c program, it consists of 5 statements. What are the 5 statements? Maybe a variable declaration int a comma b. Next is printf, enter a and b value. Next is scanf, ampersand a ampersand b. Next addition, a plus b addition, printing the result a plus b. That can be 5 statements. So the program is loaded from secondary memory to the primary memory. Okay. Next first instruction need to be loaded here. So remember, this is the memory part. This is the CPU part. The entire rectangular box we call as this one. Sorry, this one. This rectangular box we call as CPU, central processing unit. Okay. So first instruction loads from primary memory, and it need to be executed by ALU. So can anyone respond? Is my cursor visible on this diagram?
Yes, sir.
Okay, fine. Okay. So my program consists of 5 statements. That program loaded from secondary to primary memory, and first instruction need to be executed. So instead of directly executing, it need to pass through various registers. So what happens is, first step, actually my first instruction in the primary memory, it need to be loaded into IR. It is instruction register. So it is instruction register means instructions can be stored in this register. So from the primary memory, my instruction need to be first instruction in the add.c program need to be loaded into IR, and it need to be executed by ALU. But thing is, it is not directly loaded here. There are 4 more steps before this 5th step. So before to get the instruction here, first of all, what is the step is, the first instruction address is copied into program counter register. So program counter PC we call. So first instruction register in the program is, its address is loaded into program counter. So you can see address of first instruction. So only address is copied, not the exact instruction. exact instruction need to be copied into IR. For that purpose only, the first step is, you can see the address of the first instruction is copied into program counter. Next, from here, the address is copied into MAR. The same address, whatever we have, the address of first instruction, that address is copied into MAR, memory address register. So address is copied into MAR, and in the same at the same point, even the read signal. So you can see the 3 numbering had given at a time. The address is stored here, sent here, and also the read signal is sent to primary memory, saying that I am sending the read signal. You please send the first instruction. So you can see PC is sending read signal to the primary memory. Now, so what did this mean, read signal? To read some data from primary memory. If you send write signal, you can write some data into primary memory. If you want to read, you will send read signal. Okay, so these read write signals entirely they are controlled by control unit of the CPU. Okay, so here from the PC, read signal is sent to the primary memory saying that, hey, primary memory, please send me the instruction, the first instruction. So primary, you can see the primary memory responds and sends the instruction. So in response to this read signal, primary memory sends the instruction, but instruction is not sent to here. Instruction is sent to IR register via MDR. So the instruction is first sent to MDR. Next, you can see the fourth step. Instruction is sent to MDR. Next, the instruction is sent to IR. Now IR contains the instruction. This instruction which is loaded is need to be executed by ALU. And actually this IR need to be inside this box only, rectangular box. I missed it. So IR need to be, because IR is a register inside CPU. So this IR need to be inside this rectangular box only. This rectangular box only. So I understand at the moment IR is, this box is inside this rectangular box because IR is part of CPU. Okay, so IR now loaded with one instruction, first instruction. So ALU need to be executed. So if the instruction is maybe printf statement, what ALU will do? It sends the output to the memory unit, sorry, monitor to print. If the instruction is scanf statement, consists of instruction, the first instruction consists of scanf statement, assume. Then what it will do? ALU will ask, take the input from keyboards. From keyboard, maybe from the keyboard the data comes to primary memory. From the primary maybe data comes here, so on. For example, we assume that the first instruction is addition of A plus B. So what ALU we need to do? It need to add A and B, A plus B. But you don't know the values of A and B. So again it said ALU sends a read signal. You can see ALU sends read signal saying that, hey, I have the instruction in IR which is A plus B, but I don't have the values of A plus B, A and B to add those two. So it says send me the values of A and B so that I can add them. So so how it says the request, sends the request, it sends the address of operands, the address of A and B plus a read signal saying that I want the values of A and B. Okay, so ALU sends the request in this way, address of A and B plus a read signal. So read signal, we already know, we had used read signal here also. To read anything from the memory, we say read signal is sent. So address of operands A and B and a read signal is sent. So because address is sent from A to B, so obviously the A and B values are sent by primary memory. But remember, those A plus B are not sent to IR. The A plus B are sent to the operands A and B are sent to, here you can see 8th step. The operands A and B, they are copied into R0 and R1 general registers inside the processor. So primary memory, when it sends the operands, they are stored in general purpose registers, because IR can store only instructions, not operands. These are to store operands. So whatever in response to this read signal, whatever operands sent by main memory, primary memory, those operands are stored in R0 and 1. So A value is 5 and maybe B value is 6. They are copied in these registers. Now ALU can fetch these two, 5 and 6, can add these two values as per the instruction. So it can add 5 plus 6, which is 11. This ALU will do the arithmetic operations. So ALU will fetch this 5 value from R0 register, which is general purpose registers. R1 is another register. So ALU fetches 6 from this R1, adds these two, 5 plus 6, and stores the result in 11, because maybe R0 plus R1 is the instruction. So R0, R1 is added and is stored, result stored in R0. So 5 plus 6, 11 is stored in R0. So 11 is stored here. And now if ALU wants to send this 11, to write this 11 into main memory, this primary memory, we have this 10th step. Let me repeat, whatever result 5 plus 6, 11 we have in R0, that 11 need to be, if it is need to be stored in primary memory, what to do? We need to send what type of signal? It's a write signal, because 11 need to be copied or written into primary memory. So that's why a signal is sent. So what is the signal? You can see it is a write signal along with the address to store the result, where the value, the 11 need to be stored, the result need to be stored. So the address plus the write signal is sent by, here you can see, sent and to the primary memory. And so obviously the 11 is copied into primary memory, stored in primary memory, the result. If there is a printf statement, directly the 11 is printed onto monitor. Okay, so this is the scenario happens, you can see. So let me summarize once again. If I have program of 5 statements, add.c in written in C program, maybe that entire program copied into primary memory, and it is fetched instruction by instruction and processed by ALU, which is a part of CPU. So the instruction from the program need to be copied into IR. So it is not directly copied. So first what happens is, the step is the first instruction address is copied into program counter PC, and that first instruction address is next copied into MAR register, and read signal is sent to the primary memory requesting for the instruction, first instruction, to read the first instruction. Then primary memory responds with the instruction, which is first stored into MDR, next it is stored into IR. These are the registers. So remember, this MDR, IR, they are inside CPU. These two are inside CPU. So the instruction copied into MDR, next it's copied into IR. If the instruction consists of maybe any operands, so for example, instruction is A plus B, then to process A plus B, ALU wants the values of A and B. So what ALU does is, it requests for values of A and B by sending address of those A and B, the operands, plus a read signal to the primary memory. In response, primary memory responds with the operands, the A and B values. Those A and B values are copied into general purpose registers R0 and next R1, 5 and 6. Now ALU will process the data, adds 5 plus 6 because it has operands values 5 and C, A and B operands value 5 and 6. So it adds 5 plus 6, the 11 it is stored in R0, and 11 if it is need to be copied into primary memory, that left to copy into primary memory the result 11 of this one. So actually 5 plus 6, the total is stored here itself. R0 now contains 11. 5 is replaced by 11. So the 11 need to be copied into primary memory. So what it happens is the address where the 11 need to be stored and also write signal is sent to primary memory. So at that address in the primary memory, the 11 is stored. This is the scenario. Okay. So if you remember this diagram, you can write the theoretical steps. So don't draw this diagram in the exam. So this, for your understanding, I had drawn based on theoretical part. So theoretical part you need to write is these statements. First, program is stored in the main memory. Add.c is stored in main memory. Next, program counter contains address of first instruction of program. So PC is loaded with the address of first instruction of program. Okay. So entire program is in main memory. So this is the theoretical part of the previous diagram. So you need to write these steps instead of the previous diagram. So the diagram is for your understanding. So entire program in main memory. So first instruction's address is loaded into program counter. Next, contents of PC are transferred to MAR. That is contents of PC. What are the contents of PC? It contains address. That address is transferred to MAR and read control signal sent to main memory. Read signal is sent to main memory. We already seen in the diagram. So after the access time, certain time, the addressed word means a set of bits. So the addressed word. So what it contains, if here the word is, in this case, the first instruction. The first instruction is read out of primary memory and is loaded into MDR. So from the MDR, it is loaded into IR. So contents of MDR transferred to the IR. Next step. Okay. Now the instruction is ready to be decoded and executed by ALU. If the instruction involves an operation to be performed by ALU and it requires some operands from the memory, then what ALU will do, it will send its address and read signal to read the operands from the main memory. Operands are read from the memory and they are transferred to R0, R1 registers. We may have N registers. We call them as processor registers. Okay. Now ALU can perform the desired arithmetic operation, maybe A plus B, such as addition, on the values in processor registers, that is R0, R1 registers. Maybe R2, R3 can also involve, multiple registers can involve in the addition operation. The result is stored in the processor register itself. The result 11 is stored in the processor register, which is the R0 itself. If the result is to be stored in memory, that is in the primary memory, then the address plus the write signal is sent to the main memory. We already seen this one. So to write the 11 into the main memory, the result 11, then the address where it need to be written, the result need to be stored, plus the write signal is sent to main memory. Okay. So during this entire execution of 9 steps, at some point, the PC is incremented, the value of PC is incremented, the next instruction is fetched and its address is stored in PC program counter. So during the entire 9 steps, at some point during this execution of the current instruction, the contents of PC are incremented and next instruction register. When contents of PC consists of some address, right? If it is incremented, then PC is loaded with next instruction register, next instruction address. PC is loaded with next instruction address. Okay. So now PC will be pointing to the next instruction. Now, as soon as the current instruction is executed, after completing the execution of current instruction, new instruction is fetched because new instruction address is already in program counter. So new instruction is fetched. So this process goes on. You can see after first instruction is executed by in CPU, it's like second instruction address is loaded here. Second instruction address is loaded, again the same process, address sent here, read signal sent here, instruction loaded into IR, it will be executed. If any operands required, operands are loaded here, addition is done and result is stored in the main memory. Again third register address is loaded here, third instruction address is loaded here, address of third instruction. And again the same process. Next address of fourth instruction is loaded, same process. Address of fifth instruction loaded, same process. Entire program ends. Okay. Ma, is it clear for you? Let me know if you have any doubts in this part. Is it clear? Shall we go with the next topic, or if you have any queries, please let me know. So are you able to message me? Still any problem with the message part? Okay, so yeah, 70. Okay, so if you have any doubts, please you can even chat. You can specify if you want any revision or any question you have. You can unmute yourself and you can ask me, or else you can even chat. Okay, is it clear? Please let me at least tell me yes if it's clear. If you're clear with the present topic, say yes.
Yes, sir.
Okay, fine. So you can chat also, or just at least a few responses. Okay, right. Go with the next topic because this is an important one. Just I want to confirm with you. Yeah. I will once again send you with this because this is a new diagram. I made it clear. Previous one was a clumsy one, so this had made a clear diagram. So I will send this PPT also to you. Yeah. Whatever we had discussed till now is this concept from the main memory. Main memory consists of the entire program, which consists of 5 instructions, and instruction by the instruction is copied into processor into this registers and it is executed. So this is the rectangular box is the processor. So instruction by instruction is fetched from main memory to the processor and they are processed here. Okay, right. So in addition to these two, we have even input devices at the left in the block diagram, if you remember, and also we have output devices. Okay, so from the input devices, the data will come from maybe from the keyboard into the main memory, and next it is processed. And if required, that processed result is sent to output device, maybe to the printer or maybe to the monitor to see the result. We can watch the result on the monitor. Okay, this is the flow. Okay. After this 12 points. In addition to transferring, so the same statement you can see whatever I had said just now, the last few statements. In addition to transferring data between memory and processor, the computer accepts data from input devices at the left and sends data to the output devices at the right. Okay. In the block diagram. So generally input device will not be at the left and the right, output device will not be at the right, but as per the block diagram, input device at the left and this one at the right. Okay. So machine instructions are provided for the purpose of handling I/O transfer. So whatever I/O transfer from input device, I/O means input and output transfers from the maybe input devices to the output devices, to the input device to the memory, memory to the output device. So on the I/O transfers, they are done using some machine instructions. This is one typical scenario. In the last class, did we come into this slide? Had I explained this part? So I don't think so. I did not got through this statement. Okay. So one thing you need to remember is the processor maybe, for example, processor is executing my add.c program. So processor is going to fetching one instruction at a time from the main memory, and my processor is executing the instructions. So first instruction is fetched from main memory, and my processor is doing some the processing of that instruction. After the first instruction, my processor gets the second instruction from the main memory and it is executing. So in this scenario, when the processor is busy with some work, there may be in situation wherein maybe it may be in a factory, like this computer is, and there is a sensing device which is attached to the computer, and you can see this sensing device senses any fire and alerts the people in the maybe the factory or company. So what this sensing device is, if there is a smoke type of thing in the factory, it detects the dangerous situation and it sends a signal, an interrupt signal to the processor, saying that processor, please stop whatever you are doing and first respond to my dangerous this situation. So now processor, what it need to do is by looking at this interrupt signal which is sent by sensing device, the processor will stop whatever processing it is doing, maybe the executing the add.c instructions. The processor will stop executing its instructions, and it will respond to this interrupt signal. Maybe that processor may ring a bell in the factory. The response may be ringing a bell so that all the people get alerted for the situation, the fire situation. Okay, so this is the situation. So this is the same thing explained here. For example, a sensing device in a computer-controlled industrial process may detect a dangerous condition and raises an interrupt signal. So this interrupt signal is sent to the processor. Processor looks at this interrupt signal and says, hey, some quick response I need to give. I need to stop whatever work I am doing. Maybe the addition of two variables. It will stop that work, and what it does is it actually instead of what it executes a, what you say is interrupt service routine. Actually, a processor in response to this interrupt signal, it will execute this interrupt service routine. This is a program, a function. So this will execute and this will alert. It will give the response, maybe ringing the bell. So based on the type of interrupt signal, processor will execute a particular type of interrupt service routine, because there are various interrupt service routines based on the interrupt signal. So processor will execute the appropriate interrupt service routine, and thus that routine will do the needed response, maybe ringing the bell. Okay, this is the scenario. So one simple thing we can say, based on the sensing device alert, the processor will execute the appropriate interrupt service routine and it will service and does the needful response. So when the processor executes this interrupt service routine, what this routine will do is it saves all the previous work of processor into its registers, and this routine gets executed, and it does the response, maybe ringing the bell, and after executing the entire interrupt service routine, after giving the entire needful help to the device or ringing the bell and alerting the people, it's like processor again, it will be loaded into the previous processor, it loads its previous work from the registers, maybe addition of the two values, and it continues with its previous work. Okay. Okay, next is this performance. This the next topic is performance. So performance is nothing but we already know how when we say performance, if we buy a new laptop or new computer, we and your friends also, you discuss like, hey, what is the processing speed, how quickly your computer will respond, how quickly it executes the programs, or how quickly it loads the Windows operating system, how quickly it opens your Word document or maybe your any website, how quickly it responds. So based on that, we will say my computer is faster or quick when compared to other computer, right? So same thing you can say when you say performance, that's it's a measure of how a computer is how quickly it executes the programs. Okay, so this performance, the factors that